In June 2022, an American startup was deep in the running for one of the most consequential lithium contracts on the planet. They had run pilot tests in Bolivia's Uyuni salt flat, one of the world's largest lithium deposits. They had aired television ads. They had invested years of positioning and capital into the bid. Then Bolivia announced its decision. The contract went to a CATL-led consortium, one of China's largest battery companies, and EnergyX was simply disqualified. What makes China's position so difficult to challenge is not any single advantage, it's the depth of the infrastructure they built. Between 2009 and 2019, the Chinese government backed its domestic battery industry with an estimated $100 billion in state subsidies, systematically developing refining capacity, cell manufacturing, and vertical integration across the supply chain. The result: Chinese firms today control approximately 75% of global battery manufacturing capacity, and somewhere between 65 and 80% of the world's lithium chemical production and refining. The numbers vary by source, but the direction is consistent, which means that even critical minerals mined in the United States or Australia often end up being processed in China before they can enter a single EV battery. That is the chokehold. And for years, China's position seemed, in the words of one analyst, effectively impregnable. EnergyX thinks it does, and the technology it's built, one that had been commercially demonstrated as far back as 1996, then largely overlooked, and is now resurging, is what industry observers have called potentially game-changing for the global lithium supply chain. Whether it actually delivers on that potential is a different question entirely. That's exactly what makes this story worth understanding. Here's something most people don't realize. The electric vehicle sitting in a dealership near you, whatever it costs, whatever range it promises, contains a battery whose most critical component was very likely refined in China. Because that's what China built the infrastructure to do at scale, and almost no other country built comparable capacity to compete with it. And that single fact has a direct impact on price. When lithium refining capacity is concentrated in one country, that country has significant leverage over the cost of the vast majority of batteries manufactured anywhere in the world. Which is part of why, even as EV adoption was supposed to be accelerating, US electric vehicle sales actually fell 43% in the fourth quarter of 2025, after the IRA's EV tax credit cap took effect. The market is that price sensitive. The economics are that tight. Meanwhile, the International Energy Agency projects that global lithium battery demand will roughly triple between 2023 and 2030, 3 times the demand, against a supply chain where China currently controls somewhere between 65 and 80% of global refining and chemical processing capacity, depending on how you measure it, but dominant by any measure. Senator Ted Cruz put it bluntly: lithium is the new oil, and we have been sending it all to China. That's a political statement, sure, but technically, it's not wrong. Just like oil refining determined geopolitical power in the 20th century, lithium processing is shaping up to be the equivalent choke point of this one. The country that controls refining holds significant leverage over the transition. So the real question isn't whether there's a problem, it's whether anyone has actually figured out how to solve it. And that's where this story gets interesting. Between 2009 and 2019, the Chinese government backed its domestic battery industry with an estimated $100 billion in state subsidies, and that capital helped lock in a dominant position across the most critical parts of the supply chain: lithium chemical processing, battery cell manufacturing, refining. The result was a structural dependency that the US and its allies have only recently begun to seriously reckon with, and that dependency is difficult to close, at least through conventional means. That phrase, conventional means, is important because the dominant traditional method for producing lithium from brine, evaporation ponds, has structural limitations that are well documented. The process works by spreading lithium-bearing brine across large salt flats and waiting for water to evaporate and concentrate the lithium. It is slow, it is land-intensive, and it is inefficient. It recovers only about 50% of the lithium in the brine and loses roughly 90% of the water in the process. Direct lithium extraction is a fundamentally different approach. Instead of waiting for evaporation, the brine is passed through selective membranes or adsorbent materials that preferentially isolate lithium ions, a process that is significantly faster than conventional evaporation and, according to EnergyX's own company data, achieves recovery rates above 94%. DLE does come with its own resource trade-offs depending on the specific method used, but on the core metrics of speed and lithium recovery, the advantages over traditional ponds are well supported. And here's the part that matters strategically. China's dominant position in lithium was built around the economics of conventional processing, and DLE operates on a different set of economics entirely. According to the case researchers and analysts tracking this space, EnergyX's approach directly threatens China's edge in a way that scale and subsidy alone may not be able to counter. Whether that threat materializes into a genuine shift in market power is still an open question, but it is, for the first time in a long time, a credible one. Here's a question that doesn't get asked enough. If DLE's proponents are right, faster processing, higher recovery rates, lower resource use, why wasn't it fully built out decades ago? The honest answer is that it wasn't entirely ignored. DLE has been used commercially in some form since 1996, but only in hybrid configurations, never as a fully integrated, standalone system. The concept was understood, similar approaches had been explored, and then it remained on the margins of the industry, largely overlooked, for the better part of 2 decades, while evaporation ponds continued to dominate. It wasn't until global lithium demand began accelerating, driven by EV mandates and battery storage build-out, that the case for fully commercializing DLE became urgent enough to act on. EnergyX was founded in 2018 by Teague Egan, a petroleum engineer with a doctorate from the Colorado School of Mines, who saw an opening. Take the membrane-based DLE technology being developed at the University of Texas at Austin and build it into something deployable at scale. In 2019, the company licensed lithium extraction membrane intellectual property from UT Austin, IP linked to research by a scientist named Theodore Dillenschneider, whose role in the company would later become the subject of federal litigation, and the two organizations formed a joint research lab. The result of that work is a proprietary system EnergyX calls LiTAS, a membrane-based DLE platform designed to isolate lithium ions from brine without the need for evaporation. No 18-month wait, no 50% loss rate. The process cycle runs in hours, and EnergyX's own company data claims recovery rates above 94%. By March 2026, they had a working demonstration plant in Texas, Project Lonestar, producing 250 metric tons of lithium carbonate equivalent per year, which sounds significant until you see the number they've committed to: 50,000 metric tons per year by 2030. From a company that has never operated at commercial scale in 4 years. That is an extraordinarily ambitious target, attached to a company that, by its own auditor's assessment, still needs to prove it can finance and execute a commercial build-out. Whether it's achievable is the central operational question hanging over EnergyX's entire story. Let's talk about the numbers, because with EnergyX, the numbers tell 2 very different stories depending on which ones you look at. Start with the ambition. The Lonestar plant in Texas, EnergyX's demonstration scale facility, still in ramp-up as of early 2026, currently produces approximately 250 metric tons of lithium carbonate equivalent per year. Their stated target for the Texas refinery alone is 50,000 metric tons by 2030. That's a 200-fold increase in output from a company that has never run a commercial-scale plant in 4 years. The Chile project, Black Giant, is projected to produce 52,500 metric tons per year across its first 2 phases, backed by Eni's $225 million equity investment and a $690 million letter of intent from the US Export-Import Bank. For reference, the IEA projects that global lithium battery demand will roughly triple between 2023 and 2030, reaching hundreds of thousands of tons annually. Even a fully built-out EnergyX would represent a meaningful but still partial share of what the market will require. That's the ambition side. Now look at the other set of numbers. In 2024, EnergyX generated approximately $1.1 million in total revenue, against a net loss of $20.8 million. In just the first half of 2025, the loss reached another $20.9 million, bringing the cumulative deficit since the company was founded to $73.3 million. The auditors who reviewed EnergyX's financials didn't bury their concerns in footnotes. They wrote directly into the report that they had substantial doubt about the company's ability to continue operating. That is a going concern qualification, a formal signal that the company's ability to sustain operations depends on successfully raising additional capital. And here's where the capital structure gets uncomfortable. Early institutional investors, the GM and POSCO-affiliated groups who came in during the 2023 Series B, acquired their shares at approximately 85 cents each. By 2025, EnergyX was selling shares to retail investors through a Regulation A public offering at prices ranging from $10 to $13 per share, compared to the roughly 85 cents per share that early Series B investors had paid. That differential, somewhere in the range of 12 to 15 times, reflects the risk asymmetry between early institutional participants and later retail entrants. Simultaneously, CEO Teague Egan was selling up to $9.2 million of his own personal shares through that same offering, with analysts noting that roughly 15% of the funds raised through the offering were flowing to the founder rather than to the company's operations. All of this was disclosed in the public offering filings, but disclosed and prominently communicated are two very different things, and the retail investors taking on the most risk were also the ones with the least context to evaluate it. In the span of about 30 days, in the summer of 2026, the company received what might be the worst and then the best news in its recent history. First, the context. EnergyX has positioned itself as a US-based challenger to China's dominance in lithium processing, aiming to undercut that dominance through superior technology. But in June 2022, a CATL-led consortium walked into Bolivia and took the contract that EnergyX had been positioning to win. They had run pilot tests. They had aired television ads. EnergyX was disqualified before the final decision. The CATL-led group won. The company aiming to challenge China's supply chain position had been outcompeted by it on a major stage. They recovered. New projects, new capital, new partnerships. By early 2026, Lonestar was operational, and the US Army had granted a conditional land lease for a domestic processing facility. Then, on June 4th, a lawsuit landed. Theodore Dillenschneider, a chemical engineer with a PhD from UT Austin who had worked with EnergyX since its earliest days, filed a federal complaint alleging wrongful termination and equity dilution. According to the complaint, Dillenschneider claims to have co-invented the core DLE membrane technology that became the foundation of EnergyX's LiTAS system, and that his equity stake was cut by 40% through the issuance of new shares while he was hospitalized during a health crisis, a process the complaint alleges was orchestrated by CEO Teague Egan. EnergyX's response was that Dillenschneider was a consultant, not a co-founder, and that his shares had not vested. The case is ongoing. What gives this dispute particular weight is the IP question at its center. EnergyX holds nearly 100 patents on DLE and battery materials, and that portfolio underpins its entire technology claim. If the foundational research behind those patents is subject to a contested co-invention claim, the legal uncertainty becomes a question that any serious investor or partner would need to assess. And then, 32 days after the lawsuit was filed, Eni, Italy's oil major, one of Europe's largest energy companies, announced a $225 million equity investment in EnergyX's Chile project, with Chile's president present at the announcement. The deal also supports a $690 million letter of intent from the US Export-Import Bank. Eni wrote a 9-figure check into a company whose own auditors had flagged going concern risk. So where does that leave us? A company carrying auditor-flagged financial risk and an active IP lawsuit that just secured a major equity commitment from a global energy company. Both things are true at the same time, and the fact that they are is precisely what makes this story so difficult to dismiss. There is no evidence that EnergyX deliberately defrauded anyone. There is also a significant gap between what the company projects in its press releases and what the primary source documents actually show. The truth, as it usually is in deep tech, sits somewhere in the middle, and it's more interesting than either version. Here's what the record shows. The US Army conditionally selected EnergyX to build a lithium processing facility at the Red River Army Depot in Texas, a federal institution that evaluated the proposal against national defense priorities, not purely commercial ones. General Motors has maintained a strategic offtake relationship with the company since the 2023 Series B, retaining rights of first refusal on EnergyX lithium output. Eni, Italy's oil major, described by analysts as a global energy titan, committed $225 million in direct equity to the Chile project. These are not commitments that large institutional actors make without their own internal review. They don't prove commercial success, but they represent real financial exposure from organizations that had access to information retail investors did not, and that chose to remain involved. 3 open questions will determine what kind of company EnergyX actually turns out to be. Whether a company with $73 million in cumulative losses and approximately $1.3 million in revenue in the first half of 2025 can execute a 200-fold increase in production output in 4 years. Whether the IP litigation involving the membrane technology underlying their patent portfolio will resolve without materially affecting their proprietary claims. Whether lithium demand growth will remain strong enough to justify the capital required to bring Black Giant online at scale. None of those questions have answers yet, and all of them matter more than any partnership announcement or government lease. What this story points to, beyond EnergyX specifically, is a broader shift in how seriously Western governments and capital markets are taking the lithium supply chain problem. China's dominant position in lithium processing was built on roughly a decade of state-backed investment, estimated at around $100 billion between 2009 and 2019. That position is not going to be dismantled by a single startup in Texas. But direct lithium extraction, if it can be commercialized at scale, represents a credible technical alternative to the economics that made China's position possible in the first place. If EnergyX delivers, it could validate the model. If it doesn't, the technology could be acquired and developed by others, Eni, government labs, or the next company willing to try. The strategic incentive to find a solution is not going away, and for the first time in a long time, that contest is happening with real capital behind it. That, by itself, is a change worth paying attention to. The EnergyX story is not finished. Several significant developments are still in motion, and the data that will actually matter is only beginning to come in. In the coming months, a few watch points stand out. First, pilot output data from Project Lonestar, which EnergyX is expected to release in late 2026. Whether the plant's actual production confirms, exceeds, or falls short of its rated capacity is the most direct available test of whether the technology performs as claimed at demonstration scale. Second, the Dielenschneider litigation is ongoing, and as the case proceeds, court documents may surface additional details about how the LiTAS technology was developed and what ownership claims have standing. Third, how Eni's $225 million investment translates into concrete next steps for the Black Giant project in Chile, and whether the Exim Bank's $690 million letter of intent moves toward a finalized commitment. Each of those developments will carry more information than any press release, and each of them will be covered here using the same material we used for this video, SEC, and offering filings, financial data, court records, and the technical context that rarely makes it into standard coverage. The lithium supply chain is shaping up to be one of the more consequential industrial stories of this decade. The coverage it receives tends to move between promotional enthusiasm and dismissive skepticism, often without much engagement with the underlying documents. Neither mode is particularly useful if you're trying to form an accurate picture of what's actually happening. If that's the kind of analysis you're looking for, this is the right place to be.